Higher Maths Unit 3 Practice Assessment, NAB 3, Outcome 2 on Further Calculus. Now, this outcome has 11 marks available, and in order to pass it, you're required to get 8 out of those 11 marks. In the further calculus, the two things that you're meant to be able to do are 1. Differentiate or integrate sine or cos of x. And 2 of the questions out of the 4 are on this. And how to differentiate and integrate a function of a function. That is the chain rule, when you've got some function of x. Now, the derivatives and integrals of sines and cosines are very easy. They're given in the front of the exam papers anyway. I don't know why, because they're so simple. Because quite simply, sine turns into a cos, and cos turns into a sine, whether you're integrating or differentiating. It's just a case of remembering which goes positive and which goes negative. And that's actually quite easy. If you start with a sine graph, and I want to differentiate the sine graph, that means I want the gradients in the sine graph. Well, for the part up to pi upon 2, the sine is increasing. So the derivative of sine in that interval is positive. So the first part here is going to be, if you differentiate sine x, the answer will be positive cos x. And if you differentiate cos x, well, what would happen there? A cosine graph looks like this, and that's the interval for the differentiation. The derivatives, the gradients, are negative. So the derivative of cos is negative, the negative of sine x. The integrals would be the other way around. So undoing the derivative, cos would go back to sine, but sine, because it's a negative here, would go back to a negative cos. So that would be the integral of sine would be a negative cos. You just need to think it's just the opposite. That's positive, so that's negative. But don't forget plus c whenever you're integrating. And the integral of cos would be simply sine of x plus c. So question 4 then, which is the first one, for just 2 marks, will be differentiate a sine and differentiate a cos, but expressed the 2 different ways. So in 4a, it will say if y is equal to something or other, 4/7 of sine x. And of course it doesn't matter at all what this coefficient looks like. That coefficient will simply remain in the derivative. It will say, in this form, if y equals that, find dy by dx. Well, that's easy. Sine goes to cos. So you'd write straight away, dy by dx will be, keeping that coefficient of 4/7, sine goes to cos, so it's cos x. And there you are, 1 mark. Could be easier. B, same again. Only this time, instead of sine, because you've already been asked a sine, it'll ask you a cos. And probably because you've already been asked a fractional coefficient, it'll give you a whole number, or maybe an integer. There might be a negative there. For all the, well, I suppose it might make a difference. So in this case, I'll say, well, what if you've got negative 8 cos x? But this time it won't say, if y equals this, find dy by dx. It'll just say, differentiate this. Now, there's no need to start inventing names like y equals, so you can write dy by dx, or f of x equals, so you can write f dashed x. If it says differentiate, you can simply put down that operator. D by dx means I intend to carry out a differentiation of this with respect to x. And that's easy enough. Cos will go to a sine, but it goes to a negative sine. Now, there's only 1 mark for the answer, so you can either just do that part in your head, so it'll be the negative of negative 8, or you can think that coefficient will remain, but cos will go to negative sine. Negative of negative, that will be 8 sine x. There's only 1 mark for the answer. Now, the next part is on the chain rule, which is the same as saying, how do you differentiate a function of a function? Now, it may not be just one function of a function, as it is in the NAB. There could be all sorts of layers of functions of functions. The simplest way to do this is to have a visualization of these functions acting in functions. In the simplest form, if you write f of x, that's some function acting on x, it simply means that, if you like, you've got x and you can change its value, And this function is some operation acting on x. You can think like another cog acting on it. So that as you change x, the value of this function changes. And the rate at which it changes is f dashed x. For a small change in x. If the answer that's produced by f is then used again by some other function, like another cog in the link, some other function g, then g, the value of g changes according to f. That may well change according to x, but as far as g is concerned, it's f that's turning it. F turns this one, so this changes. I'm not strictly doing cogs because those arrows should face the opposite way, but I'll just do the same again here. So the rate at which g changes depends on which the rate at f changes, which depends on how you change x. And you could continue for further ones. The rate of change of each function depends on the function it's acting on, and eventually it gets down to just the x. So it'd be g dashed. Notice it's g dashed. I can't write g dashed x because g is depending on f. That'd be g of f. How does that change compared to f? So that here, the derivative of the whole thing g would be, it'd be g dashed, which depended on f, the effect, times f dashed, which then depended on x. In the simple case of turning cogs, if that was turning at a unit speed and this function ended up turning at twice the speed, and this function ended up turning at twice the speed again as that one, then overall, the derivative of that with respect to x would be 4 times the rate at which x is changing. So it's a product, and that's where the chain rule part comes in, because these parts are chained, if there were any more, are chained onto each other one after the other as you write them down. It even looks like a chain, I suppose, when you write these sort of cog representations. So there was a sort of cog representation of a function. The best way of visualising it, though, is more like an onion or Russian doll representation of functions. I could start with a simple function like 3x plus 4. Put in x, you work out 3x plus 4, you get some result. Some other function comes along and takes that result. Notice this isn't the same as a product, this is completely different from something times it. Takes that result and then does something else to it. It might do a sine or cosine of it. It might do some power of it. It might do some other function on it. That won't be covered in the higher course, so I won't mention them. Let's just say we take some power of it, like power 4. And that's the result. So I've got these two functions here. The outer one is a power 4 of something. The inner one is 3 times x plus 4. If I give that whole thing the name f of x, then what would the derivative be? Well, it's simply work your way in. Instead of having the cogs side by side, think of it step inside. First of all, as far as this power 4 is concerned, you fed it some number and it did power 4 of it. So how does that change for changes in the numbers that you feed it? Well, the derivative for power 4 is 4 times whatever it was acting on to the power 3. If that happens not simply to be x, but some function of x, which it is here, so there's an inner function that was secretly producing those numbers that were being fed to the power 4, if there's some function of x inside the workings, then you would multiply that by the derivative of that inner function, and the derivative of 3x plus 4 is 3. So that overall you would have 12 times 3x plus 4 to the power 3. Now you could get deeper layers of functions than that. You could have something like the sine squared of x squared plus x. There's actually 3 layers of functions there. You start off with this function, x squared plus x. It produces an answer. You feed that to sine. Now you have to be clear about the square. That square belongs to the sine, not to this bracket. You feed that to the sine, so the sine comes along and acts on that. And then whatever answer you had for the sine of it, this is a different operation again, you then take the square of that. If you like, there are 3 layers there. There's the square of some number. Inside it, that number was produced by the sine of some number. And finally inside, that number was produced by this function here, x squared plus x. So if I had y equals sine squared x squared plus x, Then the derivative with respect to x would be, work your way in from the outside, the last cog if you like, but it's simply with this layer, this sort of onion representation. Square something will be 2 times the thing to the power 1, whatever was being fed into it. What was being fed to this square? It was the sine of this. It was the sine of x squared plus x. Now step in and differentiate this inside part. What was producing the numbers that you then doubled to the power 1? It was the sine. Derivative of sine is cos of whatever it was being fed, and it was being fed this inner bracket, x squared plus x. What's the derivative of this inner function here? That'll be 2x plus 1. Notice that's why it's called the chain rule, because it's like these 3 links that are being chained together. But in order to do it, it's better to think of the functions of functions of functions inside each other, like the layers in an onion. Work your way through to the initial one by taking the derivatives of the outer functions, stepping in until you get the final inner function. And then you would just tidy that up to whatever. 2 times that, maybe just as well leaving it factorised. 2 times x plus 1 times sine x squared plus x times cos x squared plus x. Looks quite complicated, I suppose, writing it out that way when you started just with this little innocuous looking thing here. But the thing to realise, there were really 3 layers of functions. This inner one, this intermediate one, and then this outer one. Still, they're not as hard as that in the NAB. So, question 5, which is on functions of functions, we'll simply say something like f of x equals, and I'll just put down some simple inner one, and it will just be a simpler one. It'll only be a linear function for the inner function, raised to some power. If f of x is that, find f dashed x. And this is worth 2 marks, because there's 2 layers there. And that's quite easy then, so that f dashed x will be, and you can see the layers, those brackets almost suggest the layers, it's almost like that, and you just continue those brackets all the way around, and there's your inside. If that was just x to the power 6, it would be 6x to the power 5. Because as far as that power 6 is concerned, it's just saying, what are you feeding me? And whatever you feed me, my result for the derivative will be 6 times that thing to the power 5. But that wasn't a simple x that was being fed to it. The inner function is 4x plus 5. So I'll multiply that by the derivative of the inside, which is 4. Now the 2 marks for this part, first part would be for doing this, the 6 times it to the power 5, and the second mark is for differentiating the inner one. That means there's no more marks for the final answer, but you should still finish it off so that you've got 6 times 4 is 24 times 4x plus 5 to the power 5 for the 2 marks. Now number 6 and 7 are just on the reverses of those. 4 and 5, differentiate, trig function, function of function. 6 and 7, integrate, trig function, function of function. So question 6 for just 2 marks will be to integrate a sine and integrate a cos, one way round to the other. So question 6 then. First part will be carry out, and it will give you the instruction with the integral sign, integrate either a sine or a cosine, and there'll be 2 parts. One will be a cos and one will be a sine, either way round, and the coefficients will either be whole numbers or fractions, possibly negative numbers. If you're differentiating or integrating, coefficients don't change, so that'll still be a 4. And it's so easy to remember, cos will go to a sine and sine will go to a cos. So that will go to sine x. And then you just need to remember, sine goes to cos, that's positive, so everything else must be the other way around. Sine differentiating goes to a cos, so cos differentiating goes to a negative sine. Integrating will be the opposite way around. If differentiating cos would go to a negative sign, integrating it must go to a positive sign. So it must just be 4 sine x, and don't forget plus c. Now the 3 marks, 1 mark is for doing this. Now the other mark isn't just for writing the plus c here, because there's going to be 2 of them. I'll be writing the plus c in both of the cases. So I'll not put the extra mark in yet. Number 2, same as question 4. It'll just be a case of how are they going to word that. In this one it will say write down, and it will show the integral on the dx. The second one will just say it in words. Instead of showing the symbol, it will say integrate. Instead of that, it will say with respect to x. But that just means you put the integral sign down again, just like you'd have put d by dx if it said differentiate. So integrate. Now if that was a cost, this will be a sign. And if that's a whole number, this will probably be a fraction. Something like that would do, for instance. And then same as before. Doesn't matter what I'm doing, integrating or differentiating, that coefficient won't change, it'll still be 3/4. And sign changes to cos, again, no matter what I'm doing. It's just a case of what will the sign be? Well, if I'm differentiating, sign would go to a positive cos. Integration, that'll be the other way around, so it'll have to be a negative. That's the mark. And don't forget the plus c. And the thing is, there's one mark just for remembering to write the plus c, not a mark each time. So there it is then, 3 marks for question 6. Question 7 will be integrate the function of the function type. Only this time it's going to be a definite integral. But the function of the function type you're going to get is going to be perhaps too simple. The inner function could be something like this. It will just be a linear one, and truthfully, the only type that you can do in the higher for integration will be if it's a function of a function where the inner function is linear. If you differentiate some linear function, let's just take the general case, then that would be multiply by the power, take 1 off the power, and then multiply by the derivative inside, which is just a number a. So that if I wish to reverse that process, then it would be add 1 to the power and divide by that power, and then divide by this, so the opposite each time. Multiply by the power, take 1 off the power, multiply by the derivative, so the opposite is add 1 to the power, divide by that power, and divide by the inner derivative, but only if that inner derivative is just a number. Only if that is just a constant. None of that actually matters here, because the derivative of this is just a 1. So you're not even having to think, oh, do I multiply or do I divide by the derivative inside, because the inner derivative is just a 1. So here you're going to have some simple linear expression where the coefficient of x is 1, meaning the derivative of the inside is 1, which means effectively it doesn't matter in this question, so it's not even testing it properly, but evaluated between 2 limits. Now there are 4 marks left here for these 11, so there's 4 marks here, and the marks are allocated fairly generously to begin with, but then it takes a bit of work, just tedious work though, nothing difficult, to get the final 2. So what have you got here then for these marks? First part is, the first mark is for raising that to the power 5. There's a mark. Second mark is for saying now that's going to be divided by, so if that's power 5, it's going to be divided by 5. But also, although this isn't indicated or even mentioned in the marking scheme, strictly speaking it should be and divide by the inner derivative. But the mark here is just for saying divide by 5, because in this particular case I'm just dividing by a 1. I would have thought you'd have had to indicate that. I think I will just put it in anyway. So times 1 over 1, or if you like the whole thing over 1, whichever way you want. Because that's the way the 5's really produced. Not just this 5, but because it's a 5 times a 1. The other 1 that you were dividing by that would join it in the denominator. So it's that evaluated from 8 to 10. So there's 2 marks so far. Now the third mark is the standard one in integration, which is substitute the values in. So in this case I would have 1/5 of, and that would be substitute x for 10. So that's 10 minus 7 to the power 5. Subtract again 1/5 of 8 minus 7 to the power 5. The substitution gives you another mark. Now those fifths are common factors, so I'll just take them out. So I've got 1/5 of, and that's 3 to the 5, take away 1 to the 5, and of course you could just use your calculator in this, because calculators are allowed in the NAB. Or you could say, well, 3 to the 5, 3 to the 4 is 81, 3 81s, 243, take away 1, 242. So 242 over 5 for the final mark, and the final mark is for the final answer, not for any calculations you may or may not have done in between. So the next stage is, try the questions. So question 4 for 2 marks. First one, given y equals, find dy by dx. Well, dy by dx will be, the coefficient will remain the same, sine goes to cos, and that's the end of it. 1 mark. Differentiate sine, you get positive cos. Differentiate 8 cos x with respect to x. Now, I know I might have written y equals, sometimes it might say that, it would be doing sufficient just to say differentiate this expression. Well, d by dx of 8 cos x will be, the constant will remain the same, cos goes to negative sine though. So I'll put that negative at the front. Negative sine x, there you are, 2 marks. For 2 marks, question 5. If f of x is this function of a function, find f dashed x. Well, f dashed x will be, well, the outer function is 5, power 5, so that means its derivative will be 5 times whatever to the power 4. Looking inside, the inner function, the one that was being fed to it, was 3x minus 4. Its derivative is 3, so times 3. There's the 2 marks. One for saying 5 times to the power 4, and the other one for saying times 3. But finish it off. 15 times 3x minus 4 to the power 4. Fairly painless 2 marks. Number 6. Not for just 2, but for 3 marks. 1 little free mark for that constant. Integrate. Well, constant won't be affected. Cos definitely goes to sine. It's just a case of, will it go to positive or negative sine? Well, it'll be the opposite of whatever it did differentiating. Differentiating, cos went to negative sine. So that means that integrating cos will go to positive sine. Whoops. But don't forget plus c. Well, that's 1 mark. Integrate. Well, that just means I want to integrate. Negative 2/3, which strictly speaking could be placed outside the integral sign. With respect to x dx, well, the coefficient won't change. Sine will go to a cos, but just again a quick check. Differentiating, sine would go to positive cos, so integrating will be the other way around. That'll be a negative cos, but you could just have realised that all before you wrote this down, and then just say, well, the negative of the negative will make it positive 2/3 of cos x plus c. Now that's worth a mark, and the 2 c's together here give you another mark. I think strictly speaking you'll need to mention that once, but that's a bit sloppy. Make sure you put it in both times, but there's only 1 mark for knowing to write plus c. And finally number 7 for 4 marks. Integrating a function of a function, although perhaps in this case far too trivial a function of a function, because all varieties of the NAB have just got this single x as the inner function. Still, makes it easier for you, I suppose. Well, what have we got? So the outer function, whoops, is power 6 of something, so that will go up to power 7 and divide by that 7. Strictly speaking, I should mention, because there is an inner function, because it doesn't simply say x to the power 6, there's a function of x happening here, but it's a trivial one, it's just a subtraction. The derivative of that is just 1, so that would be divide the whole thing by 1. So I could show that, divide the whole thing by 1. But there's no marks for that. The first mark is for saying up to 7, the next mark for saying is divide by that 7. It's not very clear in the NAB whether that 7 simply means divide by that 7, or that 7 means divide by a 7 times a 1, which of course is still a 7. Then evaluate that. Evaluate that from 1 to 2. So the next 2 marks will simply be substitute, evaluate. So the first mark's for substitute, so I've got 1/7 of, and that will be 2 minus 3, minus 1/7 of, and that will be 1 minus 3. All to the power 7. But nastier in this case because of the negatives. So I've got 1/7, that's a common factor, I could just take that out. So I've got negative 1 to the power 7, take away negative 2 to the power 7. Now you could just put that in your calculator, because the third mark was for this substitution line. The evaluation, the calculation part, is up to you. The final mark is just for the final answer, and you're allowed to use a calculator anyway, but I'll just continue with that. So what I've got here is 1 to the power anything is always 1, so a negative 1, since it's an odd power, will be a negative 1. An odd power of a negative, so that'll be a negative result, but I'm subtracting it, so it'll be plus 2 to the power 7. Well, the two powers of 2 you tend to remember are 2 to the power 6 and 2 to the power 10. Well, apart from the very simple powers of 2, because they start that way. 2 to the power 6 is the 64, and 2 to the power 10 is the 10, 24. So that'll be that, just that, times 1 more 2, so that'll be 128. So that's 10, take away 1, gives me 127 upon 7 for the final mark. But you may just have done that in your calculator. And there it is, quite an easy outcome. Quite an easy outcome to get all 11 marks in.